Welcome to a brief explanation of the insertion sort. We're going to explain the theory of operation and sort of give an overview of the sort first, and then we'll look at actual Java code that implements the sort. So we'll start with an unordered list, as we did before when we looked at the selection sort, of 5 items and try and put them all into order. Now I use the term ordered intentionally instead of sorted because we're actually going to be creating sort of partially ordered lists instead of a fully sorted list as we go through. If you think about Joe, he's in an ordered list of 1, starting at the far left. I think of Joe as kind of the host of a party. He's the only one in the house right now, and so he is kind of by definition in alphabetical order with himself. The question is, what do we do with Bill when Bill shows up at the door? All right, so there's Bill, and now we have to decide what to do with him. So we're going to do a test. Is Bill alphabetically greater or less than Joe? Well, he comes before Joe. So we're going to move Joe down in the row and put Bill in front of him. And now we have the 2 people that are in the house, in the party already, in an ordered list, just counting the 2 of them. Well, you can guess what happened next. Bob shows up. So we have to figure out where to put Bob in the people in the house. We test first with Joe, and Joe's going to have to move down again. There he goes. Then we have to test with Bill. Bill's in the right place. So Bob takes that open spot, and we now have an ordered list of 3 people in the house in the party. Vera shows up at the door, and we have to do the same thing. Compare Vera with Joe. Oh, Joe's in the right spot, and Vera's going to go at the end of the line. Finally, Todd shows up. Now we compare Todd with Vera. And it looks like Todd is going to go in front of Vera. So we have to move Vera down. Next we compare Todd with Joe. Oh, and Joe's in the right place. So Todd goes in between Vera and Joe. And now we have all of the guests happily in the party and ordered. That took us a total of 6 tests. If you go back to the selection sort, that would have taken us 15. So this is one of the ways where insertion sort can be more efficient than the selection sort. It's dependent, however, on the order that the guests arrive. And in the worst case, it comes out to be the same as the selection sort. Now let's take a look at a Java program that implements an insertion sort. I'm cheating again in using integers in the code, and I'm going to use example strings just to make things easier to follow. But if you look at the code, we have 2 nested loops again, although this time the inner loop is a while loop. We're going to use that as a more complicated expression for reasons you'll see in a moment. And I've also not shown you the values in the array because the computer can't look at all the values in the array at one time. It can only look at the ones that it's comparing or directly accessing. So let's begin. Now we're starting with position 1 in our first pass through the array because in fact that first element, as we talked about, is kind of it's a sorted list already. It's just a sorted list of 1. And we're going to try and merge Bill into that initial sorted list. We make a copy of Bill so that we can free up the space that he's in. And then we look at the previous element in the array. We compare Bill to Joe, and we see that Joe is actually going to have to shift down to make room for Bill. So we shift him down. We go look for what might be another element in the array, but of course we're at the beginning of the array, so that's going to turn us into -1, and that's the reason for that more complicated while loop. We'll now use shortcut execution to note that j is now less than 0. We won't do a test, which is a good thing, otherwise it would lead us to an array out of bounds exception. And instead, we'll just go ahead and exit the while loop and complete the first pass by inserting Bill in the open position. Starting our second pass, we look at array element 2, where we find Bob. We make a copy as we did before. We then look at the previous element, Joe, and that's where we start our inner loop. Compare Joe to Bob, and of course we find that Joe's going to have to move down to make room for Bob. But before we put him there, we want to see what's in the next previous position. We compare Bob to Bill, and sure enough, Bob's going to go in between Bill and Joe. So the loop exits, we fill in Bob, and we're ready for pass 3. Pass 3 brings in Vera. We make a temporary copy again, and start the inner loop comparing with the next one before her. Comparing Joe and Vera. Oh, well, Vera was in the right place originally. So we exit that pass and basically put her back. Again, you wouldn't have to put her back, but it would take an if statement to avoid that, so just easier to put her back regardless. And now we enter the fourth pass with Todd. Make a copy, compare with the previous element, and yep, we're going to have to move Vera down to make room for Todd. We now want to check against the next item in the list. And now we find that Todd fits in after Joe, so we can exit the inner loop, put him in place, and our sort will finish because we've now advanced past the end of the array. There it is, the completed sort. And as we saw, we used 6 tests only compared to 15 in the selection sort.